Okay, welcome back. We're gonna do this one. Okay. So, let's get back into this. Last video we were talking about galaxies. Okay, we made it through these. Interactions are also key in galactic evolution, can easily trigger spiral arms. Here's ARP 87, one of the peculiar galaxies. I think I'm doing this out of the order that I watched them. I'm trying to just make sure. I don't know if I took any notes on this. Okay. On this video. I guess I was just taking images of this. Simulation of a disk and a galactic flyby. The structure of spiral galaxies. Stars move through arms, don't stay. I wrote like a current. And then he said traffic jam. Okay, so this is this notes. Theories: spirals are long-lived waves of overdensities, not fixed structures. That's one theory. Spirals shear out rapidly but are regenerated. That's another theory. And spirals are short-lived waves driven by tidal interactions. And then he said, quote, difficult to distinguish in terms of capacity to match the observations, because basically all of the models generally match the observations, so it's hard to say which one it is essentially what's going on there. Here's the flyby. And then I wrote bar galaxies connect a bar to arm, so which, of course, but I just, for note, with regard to shallograms, bar galaxy, something that has the bar across connect to the arms, the barred galaxy, barred spiral galaxy, the bar itself connects to the arms. Worth noting, I was wondering maybe if it was like poles. Maybe it's like poles and we're just kind of seeing top down. But because the sphere is missing and radius is shrunk, it looks like the poles are flattened and at the two sides. I don't know. That would be interesting. But anyway, let's keep going. Spirals are... Okay, so here's the theory slide with the three theories. Tomb Raid came up in another video. I think in the 70s or 80s, something, or even earlier. Something pretty long ago when they modeled it just like a flyby of a system with a bunch of stars and then a passing by system that interacts with it and produced spiral arms in a way where they're like maybe just gravity and it's not magnetic field related. Like essentially the video I was watching, another video, the weirdest galaxies one, or weird galaxy something, which we'll get to the pictures I took of that one, hopefully in this video. They said, I forgot what I was talking about. Oh yeah, they talk about that. That's all. That. Okay. Evidence for all from theory and observation. All of these theories seem to match generally. Hard to distinguish, therefore. Many galaxies show magnificent inner bar structures characterized by lengths and pattern sheets. Properties are sensitive to stellar disk and interaction with dark matter halos. So dark matter is very integral to interpretation of galaxies. Again, if it does exist, it seems like it would be the matrix around the shalogram kind of equivalent. Impact of interactions on structure is still somewhat elusive. And here's stars, here's galaxies across time. Strong, weak, and isolated interaction, I think. 3 simulations of a galaxy. Isolated, weakly interacting, and strongly interacting clearly change the morphology of the galaxy. So essentially they're tweaking variables to try to get a better idea of what's actually happening, what better matches observation, what best matches. What about specific galaxies? M33 is a nearby, well-observed galaxy with a weird structure. Interestingly, this is kind of like that James Webb Space Telescope one of M74 from the last video with a bunch of chambers. It's not quite... Like, maybe there's a spiral that goes out here, and another spiral that goes out here, I guess. Which kind of looks like it here. Out that way, with an inner one within here. But having a boundary there, I guess. But more chambers. So the chambers are relevant to the models, like how do we make the chambers? The chambers are therefore the result of supernovae, novae. Lots of other metrics as well, such as the velocity field of the galaxy. So red is motion away, blue towards. So here's a observation and simulation. So they're trying to model. A lot of it is trying to model, it seems. Like, here's observations. Let's match these observations with simulations as best as we can. And the ones that match the best should be most representative of accounting for the reality of the situation. It's kind of the idea, I guess. Which kind of makes sense, but at the same time is concerning when it stems from a Big Bang interpretation. Like, it's like Big Bang and then quantum fluctuations and then the light starts to appear, which then leads to gravity and gas clouds, or maybe gas clouds and gravity, which then leads to light, something of that nature, which then leads to UV light, which leads to certain interactions with particles, leading to stars and supernova, something of that nature, which lead to somewhere down the line galaxies. That kind of mentality assumes that there's no galaxies, assumes the starting state of the Big Bang. I mean, it doesn't assume, it just interprets. It's through that lens, it's using that lens, saying that lens is valid even though it's not. It's literally not scientific when it adds expansion of space. Basically, it would be like if they took this graph here and said we could only explain this by introducing a new variable. and said it's fundamental, it has this characteristic that's universal, and just drew a line that correlates and said, there it is. That correlation is caused by this thing that we call whatever, it doesn't matter. Let's say contraction of space, some counterbalance to expansion that is presently being, since the beginning of the universe, has been overwhelmed by expansion, but is also simultaneously a true manifestation of the fundamental underlying nature of the universe, and just add new complexity because of an observation that is a string of observations where there's many data points, but it's really just one distance redshift observation that could all be mapped together on a single plot and just like correlated, but not necessarily by a new process unexplained, but by a process previously known as gravity, which gravitational redshift produces redshift, and per distance due to lensing, gravitational lensing, both are known. So gravitational redshift, gravitational lensing, explaining an observation wouldn't require introduction of expansion of space to explain it, so it doesn't need to be, so it's not logical, so it's not really part of how galaxies formed. They formed much more like how atoms form, like in a system that's already pre-existing, that's in a system pre-existing, that's in a system pre-existing, and fluctuations where these systems aren't like eternally in a single state, but they're changing, evolving, they're going through supernova, they're conglomerating, they're doing all these things that lead to like ripples in the fabrics of reality that then just give life and breath to the universe as a whole and creates a living being of that is the universe, that has all of these actual layers of reality where there are observers who are so large that their building blocks are composed of the systems we're observing. Somewhere up the line, there's a living being like you and I just going about their business, carrying within them the universe that we observe, frozen in time because they're so large that their particles function on such a different time scale that it's basically like we're within a frozen moment of a larger being, but like that being is within a frozen moment of an even larger being that somewhere up the line maybe even connects back to the bottom in a way where they're within us and we're within them. Like, that's where galaxies are forming. In an eternal universe that has infinite layers, and galaxies are only galaxies because we are using atoms to observe them, which we're all mutually composed of. So because we're all mutually composed of atoms and then observing the same systems, we see those systems through the same lens. And so we see them all dependent on the mass ratio of those atoms we're using to what is being observed. So we see the sun as the sun, but that doesn't mean it's not also the nucleus of an atom. That doesn't mean it's not also an electron. That doesn't mean it's not also a black hole. That doesn't mean it's not also ether. It's all of these things. It's just we are only composed of atoms. So we only see through that window but there are all these other windows, just like the visible light spectrum is only one small window within this huge spectrum. The visible light spectrum, though, is repeated in octaves throughout the whole spectrum. So like an observer composed of certain particles will see a different spectrum of the electromagnetic spectrum as visible light. And even like being so massive that they see what we see as a star as a photon. Where even like black holes are part of the electromagnetic spectrum of a larger observer, so they're pretty much just part of the electromagnetic spectrum, which is pretty much just all ether. It's just ether, subtle to infinite in mass. That which the universe is composed of. All of which function the same, just are seen from different angles. So like the expansion of the universe is a supernova of the Earth, or the expansion of the Earth, sorry. On this expansion of the universe, I keep like giving credence to it in the words I say, like a Freudian slip, but it's just not true. So don't take it to be a Freudian slip when it really is just not true. So expansion of the Earth is really seen from a different angle because it's a system basically composed of the largest building blocks, atoms, and some larger, really, honestly, like batholiths, but still, like, there's a largest building block of which the Earth, like, peaks at, where it doesn't have systems larger than that. Kind of like the neutrons of a atom, mounds within dense systems within a larger system that are parts of and make it like an atom rather than like a hydrogen atom, which is like the most basic, and also the end, the beginning. It's like a new octave. It's like a C or an A, maybe. I kind of see C as a new octave. I don't know why. I mean, the C scale is just the standard scale, the most basic scale, so I don't know. It's kind of like that, though, where it's a new octave and repeats. Okay, let's keep going on galaxies before I rant too much about things that are just like, dude, what are you talking about? It's very based in a lot of context. Sorry, guys. It's one of those things where you can't fake it. Like, you have to be prepared to understand what I'm saying. Like, it's kind of like, instead of a school, that's an education system that like hands out, okay, here's the things we're teaching you today. Teach, they teach. Okay, we're gonna test you on that. Okay, here's the test. You did well, you did poorly. Oh, and then grade you. Here's your grade, and like judge you literally. Instead of that method, like just a method where the test is like, do you comprehend? In truth, because like to even understand the class really requires prerequisite knowledge. That's up to the individual to actually carry out the investigation into and comprehend, like act of contemplation and consideration and thought, and then understand the things that maybe they are not aware of, and then become exposed to enough context to really like piece together the validity of why this is a relevant pursuit. And like these statements are not just baseless, but are highly based in evidence. Okay. Closer look at star formation with time and position. Arms swap from more or less star formation as disk evolves. So galaxy with a blue arm, red arm, a blue arm, red arm, time, star formation rate. 10 to the -1, 10 to the 0, 10 to the 1. In the red arm, it starts out high and then drops off below the blue arm and flatlines around the same level that the blue arm started at here. Whereas the blue arm begins to rise to what maybe is like this. So it's literally swapping arms, and incredible. That was perhaps the most profound thing that I came across in my looking into galaxies these last few days. Because I frequently will mention the concept of how these like arcs form here, where it's basically like it's swapping sides. It forms over here, and then it fills out a space where it has to form over here, and then it forms a larger one, like how this is larger than this one. But like this one here was formed previously, and then this one formed larger than this one, but then the process continued where it swapped sides over here, so then this one formed even larger still, but then it reached a point where it like vented out the side of the rock, the internal pressure of the eddies, so it really just vented out of the peak and the side boundary down here, very close to here, maybe not exactly at like the very plane along it, but very close to it, and certainly related to the general like tip energy. Looks like related to current flowing around here and here. I talked about this one in this way before, where there's a current flowing both directions and they meet here. They create like a back pressure and flow out these ways. And this, I don't remember exactly what I talked about this one, 295. I'd say it's in my shallogram videos. If you're curious, more information, my shallogram videos are highly relevant to the galaxy topic. Like if you're not informed of the spectrum of shallograms, then it's just not going to compute the same as if you've taken the time to investigate and look at them and think about how they could have formed and how they couldn't have formed, which is fossilization. Like they couldn't have formed by fossilization in many instances. I've talked about this in detail. Maybe this is a good time to bring up this galaxy, or this this galaxy right here. This one says boundary merges as one because there was a current flowing that then also went off the end here and went up to this pole, while this current was more like equatorial current. Looks like this even is much more like very related to the width being maximum there. Whereas this one is very related to the height being maximum there. Possibly their formation playing part in that being a characteristic of the rock itself. See the boundary forming back here where it was etching through the rock here. So there's some galaxies for sure that I came across that maybe we'll get to finding pictures of that are reminiscent of that. Let's see, about one, let me just read these notes real quick. Generally, galaxies have about 1 star per year. Average star formation is a typical galaxy star formation rate, so it's pretty slow, but it's also like detectable, I guess, using computers, observing galaxies and noticing, oh, new star. I guess. Relationship of gas to stars and galaxies. This is obviously makes sense. Like the more ether is present, the more it can merge and compact. And like if there's just pressures pushing ether in and then flowing it in together, then it will merge and form larger ether that then occupies less space because it's like compacted and dense, made more dense, just compacting this material to the point where it actually like collapses to form a new stable nucleus that's dense, and it just consumes this material. Like if there's not gas clouds and stars, then like it makes sense that there would be less formation in the other locations, and that those are like almost like a ladder that needs to be climbed. Like in order for galaxies to exist, there needs to be enough material, and just the same, in order for stars to exist, there needs to be enough material. He also mentioned he studies flyby interactions more so than merging of galaxies. I believe because merging is more like boring. It's harder to detect like the mechanics of galaxies through mergers than it is through flybys, because flybys show these like interesting interactions, whereas mergers end up being elliptical galaxies, a lot of them, it seems like, I believe. So it makes it harder to find examples. Stars with a lot of stars but not a lot of gas will be inactive. Gas density tends to drop off with radius, but with strange features counter to trend. So there's, maybe we'll come across some images along here of the gas density versus distance. Like it's not just like a peak at the center where like the most material is generally around like a nucleus. Like it actually falls and then goes back up and then falls again. Kind of complexities exist, almost like rings, reminiscent of the Australian magnetic field. There it is. How this formed as a ring and then took the shape of an ammonite by having a current flow in it. How it had, but it had like an inner ring and an outer ring with like a open space of a relative void, an outer space of a relative void that actually seems to have existed, to have like participated in just being pushed around to shape this region from an inner like nucleus shell, inner shell, whereas the outer shell was shaped by the like flow into this space. So it had like rings of dense, low density, high density. So if this is like where gas is, like let's say the heat, or not the heat, some kind of just density that equates to what we're talking about in terms of gas. Like a lack of gas means the star's formation is inactive. No more star formation. So the stars basically begin to slowly decay, reminiscent of like a cold. It makes me think of cold. Like maybe the gas. The gas is pretty much equivalent to heat flow. The more gas in a galaxy, the hotter. I know some of the gas is cold and some is hot, but maybe, or maybe it's just like a transporter of the heat. Some way of perceiving, because essentially heat is a flow of particles of ether. Like if there's hot material and cold material, the hot material has so much heat compacted into it that it's radiating physical particles from the pressure imbalance on these particles of heat, which, like the caloric theory or something, historically, although it's been denied, is reality. It's just on lack of understanding of why it is reality and how it's reality, where it's literally just particles that radiate under pressure. Like if there's pressure around it of a higher heat particles present, more just density of these subtle systems that heat is composed of, then it will apply a physical pressure into the relatively colder material that in the original instance was hotter. So it's all relative, but it's just a pressure flow. So when there's like a high pressure, low pressure, it's really like a high temperature, low temperature behaves the same way, where it will like flow material from the high pressure into the low pressure to create an equilibrium and stabilize these out of balance systems with their environment, which is probably very important. Like it's all relative to the environment. Like the same air exists in the highs and lows as in the equilibriums, but it's just in balance. So it's not like violently moving in currents that are swirling and bringing material up, like evaporation and other things. It's more stable, where there's just an equilibrium. Certainly evaporation is happening, of course. Okay. During the interaction, the population of clouds slowly moves to one that is more massive and less well-bound. So that's something of interest. Like, it's almost like a bunch of clouds that are loosely bounded material. Like they're clouds, but they're still bounded. Like it's a floating cloud of material that's more dense than the relative ether surroundings, so to speak, but it's still not like so dense as to be like compacted into a star. But perhaps what happens is these clouds like come together and interact and then like coil around one another. Like they can't separate when they collide. They become like much more threaded together, and because they're elongated gas clouds, it's hard for them to like slip by one another. Like it's possible that they come together and one just slides past the other and they don't actually become intertwined, but it's also possible that they like collide with enough like length sideways to catch and form like a swirling in of these clouds that just start to thread around this like center catch point. That would be cool. To a degree, like not... Oh, that was the last image of this. Okay, last image of that one. I have enough shallogram images, I could even just talk about those. But let's do this one. We might run into... Let's see if I can just find it. Like, kind of like this. ARP 282. We have this galaxy this way, and then one off the top here. A little to the side, not quite centered. Also, shorter on this side, longer on this side. So it's not identical to this, but I was thinking ones like this are very related. It's interesting, this is like a disc this way, and then this portion right here kind of goes up above the back disc back here. That's kind of around there. Like this goes above it. I wonder if it's like like this. It's also not as bright. Maybe because it's just compacted material. Dark matter. It's possible. The more let me see if I can find this quote. Okay, no, I didn't quote anything. Okay, not what I thought. Okay, let's go through these though. So this is the Kaufmanist lecture, "The Weirdest Galaxies in the Universe," by University of Minnesota, Minnesota Institute for Astrophysics, Professor Julian Adele Canton, Director for Computational Astrophysics at the Flatiron Institute. Okay, so she went through a bunch of the weirdest galaxies in the universe. Definitely talked about Halton ARP and pointed out the Atlas of the Peculiar Galaxies. This one just has this really long thread, for instance. A lot of these would be really interesting to look at in several spectrums. Another one with a interacting galaxy, which it's kind of pointing at it. Like this tail is pointing at it, which we run into in shallograms frequently. I don't know if I can like quickly find an example where like at the end of the spiral is another shallogram, another ammonite. The end of the ammonite spiral is a second ammonite that's happens frequently. So I might be able to find one relatively quickly, but maybe not. I don't know. Like this one's maybe a good example. Like this is actually part of another shallogram. It's like one of the chunks in here. So if we look at the side of the rock, we can kind of see it. And up here, like it's actually, this ammonite is contained within the dense portion of a like tail of a spiral, kind of like this, like one of these chunks, just less dendritically formed, more with just like the overlays here and the arc along the side there over here. So this one is probably a good example of what might be going on here. Like with this one, like imagine there's this chunk of dark matter like this, like a rock that holds this galaxy to a larger system that this chunk didn't break away from, but is actually part of a spiral still that's embedded in a larger shallogram that this one is within. Again, kind of like this, where it's 2 and 1. That kind of thought I have, where it really makes me think maybe dark matter is legit. Because it's not really like a new underlying fundamental, it's more just like unobserved mass that would be subtle and like held in place relatively, and maybe like preventing certain flows into it, participating in creating a galactic shape, like why it forms in a disk. Like this forms in a disk because it's in a matrix. It doesn't form in a disk without the matrix. I mean, that's a pretty good point, actually, to maybe give even more credence to dark matter, where it really is just like a matrix that the galaxy is within, where we're seeing like a living galaxy. Like this system's alive, forming, doing its thing. This system's alive. I mean, maybe it even is. Like, if we were so small relative to this system that this looked like galactic scale, it's possible that we would see light here and darkness here, kind of thing. Like an actual current flow still of subtle energy through the structure. Where it literally is a galaxy. Which would mean it's possible some shallograms, like some galaxies, are like some shallograms that are like this, that are even broken pieces. They're formed in clusters where there's many. They're formed in individual ones. They have all sorts of structure depending on the like location within the dark matter that they're forming. Like maybe there really is like a boundary to the dark matter that kind of is like this edge, and the galaxy itself is kept within that shell, but it can like penetrate through it like this. Maybe this is some kind of inner, like the core, which can be like this. It can be all sorts of ways, or not exist at all. It can be a sphere. Here's maybe, no, I thought this was one of the ones that formed like a ammonite at the edge there. Pretty sure that's one atop of this one, and not actually internal. Maybe it's internal. It does look atop it, or it just like broke and like lifted out of it or dropped out of it, but was still embedded. I don't know. Okay, so let's keep going. Same galaxy. Here's another one with the 2, and it's even got a little like connection there. That's crazy. ARP 91. That's just gonna do stuff like this too. ARP 91 images. See if there's any other. It's possible that there's other wavelengths that just aren't like easily accessible. I also found a video on how to like make these images from the data. I tried to find the data. I just got too many results, so I gotta figure out how to do it if I want to try to do it. It looked like I could do it. I mean, it's tedious. I was thinking I could do it and create GIFs rather than images, so that they're animated and sequence quickly through the wavelengths, and then maybe also with a final overlaying wavelength one that's gonna last for longer, and then do something like that. That would be real cool. It would just help, and even like a description of the wavelengths being viewed in each one. To kind of explain, because essentially when they do one image, it's inevitable, there's no way around it. You have to soften details, you have to remove nuance to make 5 images look like reasonable atop one another like this. Like there's several images compiled into this, I'm sure, that then together, putting them together like this is awesome, and like it adds a bunch of cool detail. However, it does have the side effect that it also removes the individual image details to a degree, so that they can all kind of form one single image. I don't know why I'm going into so much explanation. That obviously should make sense enough that I don't need to explain it. That's also kind of pointing at it. That's a thing that with shallograms too, where they're like pointing at, they have current flows that point at things like this, maybe even at its nucleus. I don't know if that one's part of it. Just a long arm. That's right, this one had a long arm that continued over this way to over here. So let's look up, let's definitely look this one up. 248. It even, no, I was gonna say it looks like it's connected there. That looks connected, like it's got a interaction with this one too. It's interesting that one's a bar galaxy. That one maybe is a bar galaxy, but it doesn't look as distinguished as one, if so. Let's just close all these. Too many images. It's hard to find what I'm even looking at. Okay. This one's cool. I think she called it a bird, which I appreciated. If it's like a bird head up here, then this is kind of like a mantle puncture hole kind of thought is what I had. If you know what I'm talking about. My Earth Undercurrents video for the shortest reference. This I thought was more like a hair than a beak. Maybe it's a beak. I guess it's probably more likely a beak. I was thinking a beak like there, kind of looking face on. A little that way. So this is interesting. Like there's a galaxy here, there's a galaxy here, there's a galaxy here. This one and this one are connected through this intermediary, which is sideways, which points at the nucleus of each. I'm sorry. I'm just like, just eat my microphone, guys. Another one, kind of off this. It looks like it's even got like some little ramp type thing. What is up with that? So many of these I'd love to see more images of. There's another somewhat closer image of it. ARP 283. It's rather just cloudy looking. Huge dust cloud almost around this star region of the galaxy. This one's so cool. Nucleus, triangular side, pointing at something that then is an elliptical galaxy. It seems to have a connection between them out of this corner of the triangle. A opening in the triangle over here, so maybe a current flow this way into here. Let's look around at Earth a little bit. What the initial thoughts that brings to mind is this spot here. It's got like a pull here of these. And then over here, a triangular poles. But also like a backbone to this region. Possibly extending even larger out here. So like there's triangles. There's another triangle over here in the mantle, in the Earth magnetic field. Magnetic anomaly, sorry. Believe this is where basically there's like a flame. The flame, if you don't know what I'm talking about, there's so many details. The flame here has kind of a boundary that seems to relate to about here, and then it kind of forms this wedge that has like an outflow, especially there and there. There's other places like over here, this wedge. I don't know if this has a triangle per se. I'm trying to think of other triangles off the top of my head. I mean, there's also here where current flowed from over here off of North America. Current flowed this way. Water flowed over here and divided, went this way before the Earth expanded though, so the continents were much closer to each other, but it was starting to expand when this formed. But current went this way and essentially here and opened up this space between Africa and North America, and then another portion of that current divided over here and went into the Mediterranean region, I believe, and like threw it up this way. I can't even remember anymore. It's been a while since I even thought about this. Like this way maybe, and it interacted with a current going this way and down into here, which probably even is why it did that. Made these like depressions into because of two interacting currents that drove one below the other, which then etched in the regions where it was below the other enough to etch in. So it went over that way, but then there's also current coming through here across from this way and over this way, across this way generally, but also like filling here, flowing this way, bouncing off of the corner here enough where it actually like bends up this way, goes in here, runs into a current that's not just flowing this way but also flowing this way. So it like goes out here and kind of fans across here as well as going upward and down this way. So this current out of here creating these two sides, while this current coming across it this way creates this boundary where it comes out here and just fills this region here, which then produces these arcs along the triangle of the of the Azores Plateau. So here's another triangle, which maybe has relative nucleus there. I don't know. That's maybe a little off center. This one's not as arced in, and much more like an inflow that then is just held in a heart. I don't know exactly what to make of this. I'm just thinking maybe something of that nature is involved in these triangles. I wonder, does this, like maybe over here, produces like a dense mound over here that kind of behaves like the elliptical galaxy, whereas over here somewhere, or even like the here, I don't know, underneath here, because this is pretty much where this, like the center there, maybe they're underneath there. Hotspot under Azores Plateau. Like maybe the hotspot itself is more like this, where this is like the mounds of the islands, forming like a neutron elliptical galaxy, while down under is the hot spot, and then around it is like a more star gaseous type thing where it's not like forming a nucleus, it's just forming like a boundary. I was thinking something like that might have going on here though. Some current interaction that really pinched and got into what it pinched and swirled maybe. This one, the Millennium Falcon looking one, I thought was interesting as a potential. I've talked about the Scorpion, like over here, like right here. So there's an eddy flowing here of water atop the surface, flowing basically around here, and swirling in, and then it swirls into a point where then it like produces a current this way, which then produces a current this way and out and over as like a scorpion tail. Something of that nature. I can't remember exactly all my Canada related videos, like Canadian Shields, I don't know the episodes at this point. Curious case of something or other, I don't know. Oh, they're just images of the, like, looking like this, like looking like this. Those episodes I talk about, which then led me to the thought of a scorpion tail type thing going on here, where water was flowing over this way, but it also flowed out off here as well as back across this way. So there's kind of a scorpion tail here. So maybe this disc is kind of like here. And this is kind of like that, where this is like the Hudson Bay, which then connects up to the scorpion tail through the filament that goes up and over, and then to I forget where else I've came across this. Definitely Australia. I'm just not sure if it was as fundamental where else I've seen it. I can't remember. I can't remember. No, now guys, maybe here. Like, could it be Papua New Guinea related, like all the way up here? Where then it has this path going this way, which then leads to the eddy that formed here. Point is, it's a process to form a scorpion-like thing based on current flow. So that's my thought. Is this made me think of that? Also, I imagine this one's part of it. If we go back over here, like, it's not just this one. There's also one here that was generally here, adjacent to this one. So maybe it's something of that nature with that. And they're not identical in structure in terms of the layout. Like this, maybe it's going more like that in North America. But I would still say it's possible that there's a correlation between the two. Oh yeah, this was the spooky face or something. Very interesting. Some kind of opening. So if we go back to the periodic table of currents, just to this basic chamber, polygon with channel, current flow into the channel, which then swirls in the channel as a proton, producing space, and then producing mounds, which then behave as neutrons. Like the fact that there's this channel going to where these swirls are, like a current flows in and swirls against resistance and against resistance at two locations that then like light up the boundary, make it more apparent because there's some kind of boundary that all pre-existed that it was flowing into and running into resistance, just like currents do. Like they run into resistance. I don't know why exactly there would be just like spaces of resistance in space. Maybe it's related to like the larger system, like a place like Earth that is a larger system. Like if we could see Earth zoomed in enough to see its atoms as galaxies, or like its maybe not its entire atoms, but like its regions as galaxies, like this region may be highly representative of something more like this, but it's just hiding the like layer that it's supporting that's more like Earth-like, that makes it more like a continent. And I closed it. Okay, and then there's this way. Less spooky, more like an owl over here. This looks more like a skeleton head or something. James Webb Space Telescope infrared wavelengths peer through dust, see emission from dusty gas. Hubble's specialty was visual, optical, in the visible light spectrum, whereas James Webb is focused on infrared to see through the gas, which is pretty interesting. That really looks just like a engine of a star, like a star. Like I would call that like a star. Just a really big star. I'm not sure what that is. Maybe I can go like this and we can find what this is. Oh, it's nebula. That's crazy. The nebula looks like a star. A star, like it even has like a container holding the pressures in, like some kind of restraint, something that just physically bonds this gas cloud that is just threaded and connected energetically in a way, whereas this nebula pushes out, it just threads and threads and tightens and elongates into this like network that has more space between them, but is more like balancing, like counteracting the outward expansion, it seems, due to the supernova, because nebula are the results of supernova. Trifid nebula, let's look at this one. I think all nebula are results of supernova, but subject of an investigation. Okay. Its name means three-lobe. Lobe. Unusual combination of an open cluster of stars and a emission nebula. Ionized gases that emit light of various wavelengths. Most common source of an ionization is high energy ultraviolet photons emitted from a nearby hot star. A reflection nebula. Clouds of interstellar dust, which might reflect the light of a nearby star or stars. And a dark nebula, or absorption nebula, is a type of interstellar cloud, particularly molecular clouds, so dense that it obscures the visible wavelengths of light from objects behind it, such as background stars. Very cool. Okay. I don't know what to add to that right now. Let's keep going though. Sees through the dust, James Webb Space Telescope. Okay, looks almost like a shrimp in the Hubble. ARP 236. Let's check it out. I don't know. I'm not sure if I'm going to have nearly as much to say about these things initially, especially Stephan's Quartet. This one's definitely worth noting. I haven't looked into it much. I know it's highly studied. Four form the first compact galaxy group ever discovered. 4 or 5 galaxies. I think that might be 2. I don't know. Most studied of all the compact galaxy groups. Brightest member. Blah, 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 blah. So the fact that it's the most studied is highly useful to be aware of, that this exists as a possibility of something to analyze. I'm not sure what to make of it at first glance. I haven't looked through the details. Starburst region opposite of a tidal tail. That's interesting, like through them. Do I believe staggered? I'm trying to find. Someone said in one of these videos that the gas cloud and the star formation are not like atop one another, but they're staggered. And it reminded me of this region. I'm not sure if I can find this image. Let's see if I can find it. It might be in the animals. Where could it be? It would be very useful to see it. Feel free to just skip ahead. I'm gonna look for this. I'm not gonna pause it. It could be anywhere. There it is, there it is, there it is. I found it. There it is. So, whatever video this is from, Fiji Mound Builder symbol. Unfortunately, I cannot tell you what video I talk about this. Point is, these are volcanoes over here, and then these dashes over here. They have dashes on one side, and then circles on the other. If we look at the magnetic anomaly map without my drawing over it, here's Fiji. We see these here. Oops. Here is the dash part, or like the backbone maybe, with like dashes along it. These things, all these structures everywhere are like these little dashes, but the ones along the spine are along the spine, where the opposite side are these volcanoes, which are more chamber-like. They're more circular. then elongated notches. So if volcanoes are like stars, then that would kind of make sense for why they'd be staggered. Like star formation is staggered relative to the dust that is seeding them. Another angle. I don't know why these photos are so low quality. I just took screenshots of a full screen image. It wasn't this bad. I don't know. So ARP 244. If we could analyze a galaxy in the laboratory, we would deform it, shock it, probe it in order to discover its properties. Halton ARP. The peculiarities of the galaxies pictured in this atlas represent perturbations, deformations, and interactions which should enable us to analyze the nature of the real galaxies which we observe and which are too remote to experiment on directly. In general, the more conspicuous the peculiarity, the more illustrative it is of special events and reactions that occur in galaxies. If we go, interestingly, if we go to pretty much any shallogram website, anywhere that someone's talking about shallograms, they use the term auspicious shallogram. Conducive to success, favorable, giving or being a sign of future success. Oh, I totally thought they were. I was just wanting it to mean that it was like most unique. There's a bunch new ones. Oh, that one's real cool. Let's check this one out real quick. I got pictures of the ones before this one. That is so cool. Off the edge there, like in line with it. Somewhere a current either etched in or erupted out of, like the volcano. I don't know. I don't want to get too distracted. This one's pretty cool though. Lots of nuance right there. Looks like there's features within those that are interesting. Anomalously shaped. Doesn't really make sense for fossils to just have like weird shapes, extended features off the side here, like in line with this, while it bends this way. Like there's so many anomalies on these. Because they're not fossils, they're galaxies, really would be a better way to describe them. Or galaxy clusters even in times. Truly just incredible. Like that. Looks possibly related to over here. Like this tends to happen when current flowing along the surface runs into resistance and starts to wobble and interact with another current, typically going opposite directions too in places where they're like going like the opposite one another, but atop one another like this. And can open like pockets when they do that, but they can also flow like in unison but adjacent to one another, which still produces like a wobble. Can produce all sorts of things. Okay, let's keep going. So then he has a catalog. That's right, I was going to link the catalog. The Atlas of Peculiar Galaxies. He has like specific groups. The way they're currently separated is like spiral, elliptical, and something else maybe. I think a third one that I'm not even remembering. But he just kind of differentiated further, like detached segments, three-armed, one heavy arm. I can't read this. Other things. More things. Oh yeah, let's maybe check out the galaxies on the way too. Arm 12. So this one has a third arm, I guess. Here. One. And then or maybe here. 2 and 3. It's almost like these are like switching. Maybe this is how it breaks apart in a shallogram setting. Like this one. Like a full shallogram spiral forming, but then maybe like one of the arms severs off and becomes a little more disconnected and a new arm forms. I don't know. Cool, elongated shallograms can be all sorts of featured ways, like in terms of length. Some of them can be elongated like this, some even more elongated. Others are much more like physical perfect circles. Like if I can find the perfect circle one. Like this is kind of elongated. But at times, maybe we gotta go to the top. It's pretty early. Or you can take my word for it. There's a perfect circle. That's a possible shape for these to etch. This one's a little more circular. That's probably good enough. More circular than the other ones are. There's an even more circular one still, but here's a good example of what I was talking about earlier, where it spirals out like a larger ammonite shape that seemingly is related to this one, and at the tail of it is another ammonite shape within the singular shallogram. They can do this where they're like center over here and then they're really elongated over this way, but not so much that way. They tend to do stuff like this, which galaxies definitely are doing. Like we came across one doing just that, where it had a one this way, another one this way, and then it had a third one over there in that instance, where it's like layered with a connector, energetic connector, because it's energetically interacting things. It's not just shells arbitrarily in a rock. Like their chakras are aligned in ways, energy flows are aligned in ways where they're galactic in nature. Large, high surface brightness comps, I don't know. Some of them have high surface brightness, I guess. Some of them have low surface brightness. All sorts of differentiation that Halton Arp went through to try to show and shed light onto the spectrum of how galaxies form to better understand them as a whole. Another connected to spirals, I guess, is what that says. Some kind of connection going on, possibly interact. I don't know if these galaxies are actually there. They look, at least these look maybe related, I don't know. Close to and perturbing spirals. So I guess this one's perturbed by this one's presence. Goes down, up, I don't know. Narrow filaments. Filaments are kind of like this. These current flows that do this to the rock and just flow in an eddy. That as a long example, or just like the filament itself, the thread of current that's flowing within the rock when it was forming, at least, and probably maybe flowing the opposite direction in a subtle way now. I don't know. Maybe some more filament type of stuff here, connecting an ammonite shape there, ammonite shape there, ammonite there, like filamentary structures between really elongated lobe over here. Adjacent loops. I don't know what to make of this one, except for, so it is connected arms. So this one's pretty interesting. It actually connects again. That's like that one I just showed with the ammonite at the end of the other ammonite with an adjacent system even. Let's see if that's more like, I'm not completely sure that this is the chakra to this arm here. That's what I'm looking for. It's hard to tell where this formed. If that's, I guess that's related to that. Looks like the top of it was just like here and it blew off. I don't know. But like that's not in line with this. It's just not part of this. So there's definitely more going on here than two systems. That's a different one. So that kind of thing is going on here, it seems. The peculiarities of the galaxies pictured in this atlas represent perturbations. Okay, we read this, which should enable us to analyze the nature of the real galaxy. How do we make sense of what we're seeing? ARP and contemporaries had some ideas. Quotes, I guess, is Halt NARP, or maybe, I don't know. Probably the only agency likely to account for this is that of magnetic fields. So this is the initial interpretation back in when this was being considered, which has since become gravity. Maybe both. I feel like both, which are really just different scales of the same phenomenon, really. Just like I was talking about in the previous video, where gravitational redshift can be explained, or cosmological redshift can be explained by gravitational redshift and gravitational lensing, where figure 8 is emerging out of gravity, which is a magnetic field. So magnetic fields are producing are produced by gravity, so it's really just different scale, same phenomenon. It's just gravity is like macroscopic interactions where magnetic fields are more subtle particles that are then still interacting through gravity with other systems. It's just then they're being caused to flow in fields because that gravity is overwhelming them and causing them to flow in a magnetic field. And the scale of the particles interacting is so exponentially different that it's not like a star and the Earth that we're analyzing anymore. It's like a star and nothingness. Like the most subtle particle. The presence of the star is going to just overwhelm it and produce a magnetic field out of moving many particles like that, not just one. That interconnect regions of a wholly or partially ionized gas. Vorontsov Velaminov has stressed in the past the probable magnetic nature of some of the effects of peculiar galaxies, the connection between the plasmas observed with the radio telescopes and the optical evidences of the plasma effects pictured in the present atlas is now open to us. I'm sure there's a relationship that needs to be accounted for. But at some point, here's Toomray and Toomray enter 1972. Okay, so I was right. 70s or 80s, where they modeled a passing system that gets perturbated by, or a system A, the blue one, gets perturbated by the passing system that then causes it to lose mass. One second. And then they just interact and create out of a disk a spiral arm type structure. That's kind of the concept that Toomray was putting forth, that a elliptical type galaxy could be transformed into a more interesting galaxy by perturbations through gravity, though, whereas like portions are ripped off by the passing system, other portions are retained, and then like this, other portions are like pushed off. Maybe, I don't know what exactly it seems like not all the things are labeled here. Tidal tail is formed out of that. I guess these are lost to the dark ones. It looks like an asterisk here, but I guess it's that. Where these are captured, and these are the bridge, like the thread between. So that's the concept. These may be examples of the most important galaxies in the universe. That one looks kind of like bird wings. Fundamentally, these are galaxies out of equilibrium, so it's kind of like a snapshot of a reaction taking place. Okay, how far am I? I should probably stop here. To understand what I mean about out of equilibrium, we first need to talk about what makes galaxies do what they do. Stars, gas, dark matter. Here's stars, here's gas, I guess. So they're different. Like in terms of how the gas tends to conglomerate into chunks, or I forget what they call them. And then a dark matter halo is said to be around it. We're still unclear. Stars and dark matter simulation. Here, where the stars are that much and the dark matter is thought to be that much. It kind of looks like a shallogram. Like if you overlay the two. Like an ammonite inside of a shallogram is possible. So again, it makes me think maybe dark matter is legitimate. Dark matter aggregates, but doesn't interact. So it doesn't blah, blah. That's the reason I doubt it at times, like that it doesn't interact. I mean, the only reason that it doesn't interact kind of makes sense is it's like relatively doesn't interact, like in a shallogram sense, like the current flows here, but over here it's like more so just forming the matrix that current flows through at a point, but like really is focused through a channel here, and it's not like interacting across here as much. It's more holding a boundary. So it's possible that there is something of that nature to it. It's most of the mass and controls where things go, which adds to that it's possible it is something like that, where it is most of the mass because it's like the matrix of the rock. Gas is a big mess. Gas is moving everywhere. Stars super useful for figuring out ages. Newer stars are, I think, redder, and older are bluer. Gas hard, or maybe vice versa, pardon me. Gas hard, but we can cheat. Dust. Lumps from recently formed star signs that something rammed into something else. Okay, I don't know. Let's just keep going. Nebula. Okay, I mean, I just took pictures along the way in case something. I mean, this is very interesting. Unfortunately, they're not the best images. For some reason it didn't do it very well. The screenshot. So cool. There are several locations on Earth where there is a bird head, literally a current flowed out here to that spiral, flowed out of the bird's beak. This way and spiraled. So out of this bird beak, it's got a bird head. It's got maybe something reminiscent of the cloud, like the way this is. That'd be crazy. The clouds were like somehow representative of mountains in this instance. Is what I was getting at. That would be crazy. But then over here, we also have the bird head. Current flowed out here. It's not exactly out the beak, but like from below the beak. So kind of like at the boundary concept that we're talking about with the volcanoes and the actual current flow location of the blue. It's almost like the current flows and pushes material over and then like is able to get into that and like open a pocket to store the current of magma that was flowing, that was hot, and hold hot magma, and just enables volcanism there. Okay. Let's really try to get through this and then I'll be done. 142. Young blue stars. Okay, so blue is young. Red is older. But why doesn't gas line up with the newly formed stars? Why the arc and the fan? So this is kind of what I was talking about. So this is probably where it came from then, is this part of the video. Hot high pressure gas pushed the dense gas away. So there's this concept that maybe there's hot high pressure gas here by this elliptical galaxy. It's like physically surrounded by a even larger pressure outward, just holding boundary for the current to flow along, kind of thing, pushing the gas out too. I don't know why exactly, like because of some other resistances that are not as visible as this, maybe. This is what Hall and Arquist saw when he said these are peculiar, and oh my god, the differences. The potential in us is looking at these galaxies more and getting really good images. This one's incredible. And she even said it looks like it's pooping out galaxies. And I said that about Africa. Pooping out islands over here. That even, like, continues in up over this way. Around and up and over here. And possibly connects over to these, like, here's a triangle, here's maybe a triangle, to like a large triangle, that this triangle is a corner of the triangles and feeds into / out of, to go, like, something going on here. I mean, this is rather galactic looking itself here. So that's kind of interesting that this galactic looking, like, nucleus of Africa resembles having adjacent little systems spawn off it like that. Another one. It's kind of interesting. This one's crazy. Like, it looks like it punctured it and pushed out the boundaries. And we see a void formed by this moving through it. Or I'm not sure. I think that's what she said. Like, this went through that, I guess, is the interpretation. And that's it. Okay, guys. Cool. Appreciate it. Glad to be back a little bit. It's been a while. A week, or at least a week. I think 9 days. 10 days. I don't know. Haven't really felt like making videos at all. I barely scratched the surface of what I've been looking at, really. In some ways, a lot of what I came across is probably going to be lost in the muck of it all, because there's just a lot of stuff. I don't know if I should necessarily document everything anyway. I feel like maybe I'm killing myself doing that, so maybe not that. Till next time, peace.